Ladies and gentlemen, welcome back to the next video today. Let's see if I can change my camera. We're going to be talking about the next part. Now, I already did. You already did geometric mean once, okay? We talked about what it is, where it comes from, how it's different from the arithmetic mean, how to calculate it, how to simplify the form, and how to test if it really is the geometric mean. Alrighty? Today, we're going to be using it to solve triangles. You already know. All right? I mean, if we're doing it, it's probably for triangles. The good news is, guys, I swear we are so close. We are so close. Next time, when we come back on Monday, on Tuesday for B-Day kids, Wednesday for A-Day kids, if you're in honors, we're going to take triangles and murder them forever. That's right. We're going to learn this thing called trigonometry. That's going to make this all trivial, which means like really, really easy. So anyways, here, right triangle similarity is the crux of what we do in this unit. Now, the geometric mean, you'll have to know what it is and know how to calculate it. But, and the geometric mean can be used to solve problems like this with the triangle, but you don't need to. You can use triangle similarity if you're more comfortable with that. If you're the kind of person, and just like I said in class, same thing, okay? If you're the kind of person who can look at this triangle, take it apart in your head and flip it around and move it around and do all the cool things that apparently that's possible with, some of you guys, then awesome. Just do triangle similarity. It'll never fail you. So there's no reason to need to memorize all those rules. However, if you're an algebra person and memorizing things is easy for you, then that's the easy route. So I'm going to try and show both ways in this example, but here is where the triangle similarity comes from. All right? If you take any right triangle, so in this case it's triangle ABC. This is the first one. Alrighty? A is up here at the top. Do you see that B has a right angle? So I'm going to do B. And I'm talking about this big one, the biggest one here. And then C over here in the right corner. And I'm just going to mark this with a right angle to know what we're talking about. Ooh, got it. In this case, the next biggest triangle is this one, the triangle A. So if this one is ABC, then this is ADB. All right, ADB. And in this case, the reason this angle is a right angle is because this is an altitude of the triangle. So notice, this triangle has a repeat angle. It has A here and A again. And if you look in this triangle, you guys see that this big one, and then do I have another color per happenstance? Yes, I do. We have a red here. Let's see. So there, this red triangle and this triangle in black on the outside both have this angle in common. It's literally the exact same angle. So, of course, it has to be the same. Okay, this is the reflexive property of angles. So do you guys see here? These two triangles are similar by angle. Very cool. Similar by angle. This means they're proportional. You can multiply by, you can multiply this triangle by a number to get this triangle and vice versa. That's not a coincidence. This happens every single time. We just proved it using the angle theorem. So we'll keep going. The next one is this darker triangle here, the teeny tiny one. It shares C. So I'm going to draw it here again. This vertex is C. At the other side, we have B for the top of this triangle. And then D is its right angle. And sure enough, I'm going to use two tick marks here to show that it's a little bit different. Alrighty? But it has the same as, I meant to do C. All right, of course it will end up being the same. But really, we see that it's the same as C reflexively. So these triangles are also similar by angle. So these triangles are like Russian nesting dolls. There's a big papa one, we got the medium-sized one, and then the tiny baby one, all right? And they're all brothers. They're all multiples of one another. They're dilations of each other, you could say. So anyways, without further ado, the way you see this in the problem, and whenever you're going through the problem, you're going to want to set this up so that those triangles are in order, so that it makes the most sense to you to write a proportion. So, in this case, for example, PQR is the biggest triangle. If I was doing this, I would just let the biggest triangle decide, how the order is going to go. And here's the right angle, and then I see that P is shared with the medium triangle, and it always will be. That'll always be the case. Ready? P, well, not the letter P necessarily. So PS, and then Q here. And now note that Q is a repeat. Like, Q is a repeat letter. It's a repeat point in these triangles. But look, Q in this triangle is only part of this angle. It's not 90 degrees, right? So our 90 degree goes here at S. Excuse me. And, of course, the last one we have is the teeny tiny one, which is the top is Q up here, and then RS. Alrighty? No shame if, during the test, you want to spin your paper around and look at all the different triangles and see, you know, what size they are and all that stuff. Nothing wrong with that. Anyways, what we could do, we could say triangle PQR is similar to triangle PSQ is similar to triangle QRS. Oops, didn't write my triangle symbol. This is the similarity statement I would go for. And since we've learned that similarity is transferable, right? Like if these two are similar, then also these two are, right? All three triangles are similar. Anyways, why do we care? Turn the page. Why do we care, Mr. Shirley? So what? These triangles can be divided into similar parts. Great. Here's why we care. That means you can take apart these triangles and relate them to each other. So what I'm going to do, actually, I'm going to go back to the previous page for 1 second. You don't have to if you don't want to, but I'm going to go back to the previous page for 1 second and write. I'm going to label these triangles a consistent length that we're going to use repeated. So this length is A, this length is B. I'm going to call this entire length C. So A, B, and C is the big triangle, and then I'm going to have D on the left, E on the right, and X for the height. Okay? I will always use these letters consistently when dealing with a triangle to try and avoid confusion. Alrighty? And notice the use of lowercase letters to indicate that these are variables. Well, I guess you can't tell for C, but I promise that's lowercase. Lowercase letters means variable, all right? Capital letter means point. So, turn the page. That's what I'm going to be doing here. I'm only going to write the important ones on the first step. So, here, for example, the altitude is X. The segment AD, I'm going to call lowercase d, and the segment DEC, I'm going to call lowercase e. All right? So, in my example, let's see here. What am I trying to say? I'll show you guys where the geometric mean comes up by getting some similar triangles. Try now, on your own, to relate these two triangles. You guys see which, well, I guess first of all, determine which two triangles we care about, which of the three. And then, can you make a fraction? Can you make a ratio between these triangles that you can solve? Or a proportion, I should say. A proportion would be a better word here. Alrighty? Pause your viewer now. Adventure Time reference. Alright? Pause your viewer now, ladies and gentlemen, to ensure you have some time to try it. Anyways, now that hopefully that you tried, I'm going to say X divided by D is equal to E divided by C. Whoa, 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 whoa. Cannot believe I just did that. It should be X. I'm sorry, E divided by X. Look at this. Look at this, bro. I'm just saying stuff. Of course, I don't have any whiteout. Naturally. Oh, what did I lose? Okay, I don't know what happened to my whiteout. No big deal. Okay? We're just going to pretend I did this. Look at that. Fixed. Okay? E over X. So, now that now you have a fraction, you can cross multiply and divide. Well, I guess first let me explain. Here's how I got my fraction. Here is the medium triangle. Okay? If I look at this medium triangle, I'm turning it this way in my picture. I see that the long leg of the triangle is D, and the short leg of the triangle is X. So I'm going to write that on this triangle. These are my knowns, you could say, my givens. Okay? And over here, I have the baby triangle. This is the baby one. I notice, how did I know to do these two triangles? I saw that the medium one had two things known about it. Like in this case, in a word problem, these lengths would be given to you, right? And then here, on the short triangle, I saw it also had two things given about it. So that gives me warrant to relate them. And notice they share X. So these guys are obviously both make up part of the altitude, so they share X. That will come up in our proportion here, alrighty? And E goes down here. So short leg is E, long leg is X, long leg is D, short leg is X. Then when we set up our fraction, our comparison is as such. Do you guys remember highlighting? Our comparison is such. X over D is E over X. There's our proportion. And so the geometric mean, now you can solve this problem like this every time if you want to. But if you're a memory person, you can just recall that x squared is going to be dE. Or, better yet, x is the square root of dE. I personally would use the top one, because sometimes the missing value could be d, the missing value could be e, you know. And then you don't want to have to spend time on doing the square root unless you just want to. Up to you. These forms are equivalent. Doesn't matter which one you use. Anyways, let's try the next one. So now that you got to get an idea of what I'm after, I encourage you, try and find this one over here. Can you relate A, this length D, and then the whole length C? Can you find the two triangles that are related enough to form a proportion relating A, D, and C? And the goal here is actually to solve for A. So, pause your viewer now. Wow, pause your viewer now. Here's your chance. I don't even know what Jake looks like, but I'm going to try. Oh, no. And then he has like the, right? It's been so long since I've seen the show. No, it's here. It's here for sure. Yeah, ooh. And then he has like dark circles. I swear he has ears, right? Bro, I swear he has ears. They're not up here though, like fins, are they? Maybe it's like this? I don't know. That does not look right. Finn is really easy to draw, but Jake is not. Anyways, okay, so no further waiting. Let's try these triangles. We got this. Okay, the hint is the big one. We're going to use the big one here. So this is like big brother triangle. I'm looking at ABC here. And I see that we know A and we also know C. A is the long leg. C is the hypotenuse. And that's similar to the medium triangle. Notice that nothing is stopping you from doing this with the tiny triangle. It's just in this case we're using the medium one. If you had been given B, you could do the same thing. All right? We're using A, D, and C. But if you were to get B, you would have to use E and C. Okay? Anyways, so over here, we see, what was I doing? Yes, D is the long leg of the medium triangle. So this piece here, long leg of the medium triangle. And then finally, A gets reused as the hypotenuse of the medium triangle. So, since these guys are both long legs, these guys are both hypotenuses, hypotenuse, I don't even know the plural for that word. And then, since these and these are also on the same triangle, we can relate them. So our relationship goes this way. We're using like, these are both hypotenuses, hypotenuse. These are both long legs, and these are on the same triangle. So our proportion will be C over A is equal to A over D. Did I really just do that again? There's no way. Oh, no, that's correct. That's correct. Beautiful. So, anyways, you could cross multiply here to get that A squared is equal to CD, or likewise, A is equal to the square root of CD. All these forms are equivalent. Nothing is stopping you from using whichever one you so desire. In case you are a memory person and you're curious, yes, you can also use the tiny triangle. B would be equal to the square root. So B is what you would solve for here, and you would get E times C. Okay, so you would get CE, or B is equal to the square root of CE, is also true. So really there's only, if you're a memory person, there's only two cases you can do here. There's an inside and an outside. If it gives you the altitude, that's an inside problem. If it doesn't tell you the altitude, if you know nothing about it, or let's say not that, if you don't use the altitude in the problem you're specifically doing, then this is an outside problem, okay? Outside finds A and B, or I guess you can use it to relate anything, but A and B are typically found. Inside relates X. Beautiful. We're already at 14 minutes, but I think we're going to keep going here. We only have 4 examples to do, and I'm pretty sure 8 is impossible. So we will try them. Alrighty, let's see here. I encourage you guys, the best way to do this, again, of course, I'm going to work through and show every little detail that I can think of, but what's best for you as the student is to attempt this, even if you get it horribly wrong. That's okay. The only way to learn is to grow. You have to make a mistake so that you have somewhere to grow from. Does that make sense? You have to start somewhere so you can grow from that. So please try this, even if you get it horribly wrong, okay? And then adjust. Look at what I did, or what I'm about to try. And not to say that what I'm going to do is not the only way to do this. There's a million ways. If you get the right answer, then by all means. But anyways, without further ado, I'm going to do this first one with similar triangles, okay? I'm going to draw the similar triangle method. So the first thing I see is that, like, how do I pick my triangles? I'm going to pick the medium, and I'm going to pick the small triangle. I see that the medium triangle has two things on it. That's what I'm after. I see that the small triangle also has two things on it, 8 and x. This one is 12 and x. So I'm going to draw my triangles. Here's the medium. Here's the small. Alrighty. The short leg of the medium triangle is x. The long leg of the medium triangle is 12. And, excuse me here, the long leg, because like look at where the 90 degree is. The long leg of the small triangle is x. And the short leg is 8. You know you've done a geometric mean problem correctly if you duplicate a number. It doesn't have to be your variable. It could be anything. But if you duplicate something, that's how you know. So now I would set up my fraction as 12 over x is equal to, excuse me, I can't believe I just did that, 8 over x over 8, goodness. And then here, just anytime you have two fractions equal, cross, multiply, and divide works every time. So I'm going to do 12 times 8, which is 40. That is not true. That is just not true. I'm so tired. I need to go home. Oh my God. Okay, 12 times 8 is 80 plus 16, which is 96. Alrighty, and we'll take the square root of that to get that x is equal to the square root of 96. Alrighty. And in here, I think there is, what do we have here? We have a factor of 16, I think, is the biggest factor. You know what? I don't know. I'm not certain, so now's a good chance. I'm going to use the calculator trick here to simplify this. Alrighty, so I'm going to go into y equals. I'm going to type what's in my radical, which is the number 96. Excuse me, 96. And then I'm going to ask the calculator to check for every possible perfect square. So I'm going to divide by x squared. Now the calculator will look at every number. Every number, it'll plug in for x. So I don't want the graph. The graph is not very helpful. I mean, I can't do anything from this. Alrighty? If you're curious about its shape, talk to me later. And then we'll do second table to see what's going on here. And now I'm going to scroll down until I see the biggest number. So look, do you guys see here, like, this is 0.96, this is 1. I can't do anything less than 1, so I'm going to go up until I find the biggest number, and in this case it's 4. So I was correct. 16 is the biggest factor, biggest square. So we're going to get 4 root 6 for our answer here. So x is equal to 4 root 6. If you're a memory person, you should be clicking your heels, all right? Because that process works every single time. So this is the method of similar triangles. You can see it involves like literally taking apart the triangles. The difficulty here is this. If you can take the triangles apart and set them up, then this method is easy for you, okay? Because after that, you just cross multiply and divide to get your answer every time. Or cross multiply and a square root maybe to get the answer every time. Now, I'm going to do this one like a memory person, okay? If I'm a memory person, I'm asking, is it in or out? Well, I know the altitude, or I should say the altitude is involved in the problem that I'm about to do. So this is an inside problem, which means the altitude, x, is equal to the square root of d times e. Okay, so now on my triangle, I need to correctly label all my parts. So in red, I'm using my memory to recall that the altitude is x, this length is e, and this length is d. But the problem is, if I want to plug this in, I don't know d. So the memory person should see here, 37 minus 5 gives me 32. Alrighty? And now that I have 32, I have d. Now that I have 5, I have e. And x is what I want to know. So we're ready to solve. We'll do x is equal to the square root of 32 times 5. Alrighty? I see that 32 has a factor of 16. And then I'm going to get 4 root 10 for my radical. Okay? So I just took a factor of 16 by 2. 2 times 5 is 10. 16 comes out as a 4. It's a pair of 4s. Alrighty? Whoa, 6 o'clock. Gotta go home. Okay, anyways. I almost asked, are there any questions? Like you guys could hear me. Like you could talk to me. Okay, you could This method also works every time, but the tricky part for the memory person is going to be, what do I know? What do I not know? Can I fully label the triangle? And if I get the result, am I plugging in everything correctly? So if you're an algebra person and sorting out variables and looking through the equations is easy for you, then this should be your method of choice. All right, I mean, we have free will. You can do whatever you want. But this method might work for you better if you're memory. This method might work for you better if you are spatially oriented. And more so, I should say, this is the future engineers, future mathematicians, computer scientists, data scientists. If this is what you should be doing, okay? People who are going to be nurses or doctors or surgeons where math is involved, but maybe you won't be doing it as much. This should be what you do. This is what your brain may like. And that is just a guess, not true all the time. Anyways, we won't bother with these last two. Because if you're a memory person, this is an inside and an inside again. However, I will quickly show why I think number 8 is impossible, and then I will do am I missing a page? Uh-oh. And then I will do I have it here, the 2 other problems for the outside examples. Alrighty? Oh my god. So anyways, why I think number 8 is impossible. This is an inside problem, so we need to relate C and D here, or I should say D and E. This is E. But the problem is, if you want to find E, let's call it Y. Alrighty? So if you go to solve this problem, I guess we already called it E, so I'm not going to do that. We know that 21 squared is going to be equal to, so the altitude squared is equal to, or altitude equal to square root, right? Altitude squared is equal to 30 times E. And now I'm going to solve for E. So I'm going to divide both sides by 30. And I get E is equal to, 21 squared over 30, which is, in the calculator, let's see here. 21 squared divided by 30 is 14.7 exactly. Now that is a terminating decimal. So if you want to use a decimal point there, that's okay with me. 14.7 is no different from a fraction in that case. Alrighty? Anyways. Now the problem is, I need this length to be 14.7. So what is x? What is x? Well, x would have to be 30 plus 14.7, which is 44.7. Alrighty? And actually, what was I going to say here? Oh, yes. Well, if you solve it this way, this is the way that it works. Alrighty? I had a student earlier, though, do this. So we can see there is an answer. We see x is 44.7, and that makes sense. Alrighty? But if you solve this another way, you get something crazy. Can you imagine? I had a student earlier say this. What is this length? Well, you have 30 here. You know the total length. So isn't this length x minus 30? So the way they solved this problem was by saying 21 squared is equal to the square root of, and then they did, not 21 squared, but 21 is equal to the square root of x minus 30 times 30. Pretty cool. And anyways, whenever they did this, they made a squaring error, did a whole quadratic formula, got something crazy. So just be careful. You know, the method you choose can help you out. All right, turn the page. Last thing here, then we'll go home. I guess you're probably already at home. Must be nice. Let's see. This is, yes, here. We'll try number 9. So let's do this similar triangle way first, and then we'll do memory on this one. So, similar triangle method. For me, I see, and actually I would encourage you, see what I get on the memory. Like if you're a similar triangles person, try this as a similar triangle and then see if you get the same thing I do as a memory. Okay? Anyways, so similar triangles here. I see we have the big triangle. So this is like a kind of a giveaway here. You're always going to use the big triangle if you're not seeing anything on the altitude. Okay? Another way I see is the big triangle, 2 things are known. 24 plus 2 is 26. So 24 plus 2 is 26. That means the whole length of the big triangle is 26. And the long leg is x. Then I can relate that with the medium triangle. The medium triangle has a hypotenuse of x, but a long leg of 24. So when I set up my proportion here, I'm going to do x over 26 is equal to, so I did x over 26, I'm going to do 24 over x. And then you know you've done it right if your x's oppose one another. And we'll get x squared is equal to 24 times 26. And I'm not going to reduce this right now because I have a plan. I'm going to say x is equal to the square root of 24 times 26. It's not always in your best interest to simplify, in quotes, because here I notice there's a factor of 4 and 6. Alrighty, this guy has a factor of 2 and 13. So let's write it out. We have 4 times 6 times 2 times 13. 4 and 6 make this guy. 2 and 13 make this guy. But there's another factor of 2 and 6. So this is 2 times 3. So notice, I have a pair of 4s here. You guys see this? Sorry, there's like a big, right here on my paper is a big recording thing, so I can never see. I keep lifting it up thinking I'm not, you guys aren't able to see. This is, here we have 2 pairs of 4s. Here's one 4, here's another one. Alrighty? So the 3 and 13 stay. 3 and 13 stay in the radical. 13 and 3 are both prime. So we'll get a 4 on the outside because we have a pair of 4s. And then on the inside, we'll have 3 times 13, which is 39. Okay? Very nice. Look at that. So, for this final problem here, we're going to do memory. Hopefully, memory people got the same answer. Now, memory people, let's see what we got. So, notice in this problem, I will not be using the altitude. So, this must be an outside problem, or exterior, it's sometimes called. If you go watch Khan Academy or what's it called, Chemistry Tutor or something like that, they may call it exterior. I'm not certain. Doesn't matter. It means the same thing. So what we could do here, I notice, since this is an exterior problem, I know that A is going to be equal to the square root of, and let's see, let me look back at my paper because I'm not a memory person. I don't know. I would see that A is equal to, let's see, the square root of C times D. So, and guys, memory people, just remember, these formulas are not given on the star chart, so this is something you would have to know. Alrighty? And now, if I label my triangle correctly, I see that this side is A, this side is B, so these are the legs of the big triangle. C is 12, and then I have D and E here. Okay, so the memory person should check. I know that A is X. I know that C is 12. And I'll be multiplying by D, but I don't know D. But I do know that 12 minus 7 is 5. Hopefully you know that. Wait, is that correct? Just second guess myself. Yes, okay. So we'll put a 5 here. And then I see a factor of 4. So I'm going to take out my factor of 4. There's a 4 times, this is a perfect square, 4 times 3 times 5. Alrighty. Oh, wow. 3, 4, and 5. No way. So 4 is a perfect square, so we'll get a 2 out of the radical, and we'll be left with 15 on the inside, since 3 times 5 is 15. 4 is a pair of 2's, so a 2 comes out of the radical. Alrighty, and we'll check that is correct. Oh, I meant to box that in. No wonder why I did that. I'll box that in for my answer. All right. So look at the difference here. Memory person spends a lot of time maybe like labeling the triangle and then trying to remember the formula, but then, boom, answer. Memory person spends a lot of time figuring out where the triangles go and making a fraction, but then, boom, answer. So really, I don't know. It's a trade-off. I can't decide. I really can't decide which strategy is best. It really does, like, depending on the kind of person you are, you really do go both ways. So anyways, guys, that is all I'm going to do for the time being. I challenge you to find out the answers here, all right? Here, you'll have to choose. They give you a bunch of room. You'll have to choose which order you want to find your variables in that suits you the best. Okay, without further ado, I'll see you guys in the next video.